All right, let's do an example of a density problem. Here, I've made an example about an Olympic pool that has a volume, of 2,500 meters cubed, cubic meters. That's big. If the pool were filled with water, what would be the total mass of the water used to fill the pool? Okay, so here we have a volume of water. There's 2,500 cubic meters of water, and we're asked, what's the mass? Okay. Hopefully you realize by now that density is the key idea here. Density is the relationship between the mass of something and the volume of something. Okay, and different materials have different densities. You might remember from the last video that we looked at the densities of all these different materials here. Water has a density of 997 kilograms for each cubic meter. Okay, so you say, okay, for 1 cubic meter we have this many kilograms. So for 2,500 cubic meters, we're going to have 2,500 times 997 kilograms, right? Because for every one of these cubic meters, we have 997 kilograms. Okay, so this is just a matter of multiplying two numbers. If that wasn't clear to you, let's look at the formula. We know that density equals mass divided by volume, right? Well, the density of water is right here, 997 kilograms per meter cubed. That's D. Right? That equals m over v. Well, what's m? We don't know m. We're trying to find the total mass. So we don't know m. Let's leave that as a variable, m over v, my volume. Oh, I know my volume. That's the volume of the pool, 2,500 meters cubed. Okay, I'm putting units in here so that I keep track and make sure my answer is in proper units. My answer is for a mass, so my answer should be in some unit of mass. Okay, so I've got an equation here. I need to solve for m, right? Let's get m by itself. M is dividing by 2,500. How do I cancel the 2,500? It's dividing, so I need to multiply. Okay, we'll multiply both sides by 2,500 meters cubed. Okay, over here we have 2,500 divided by 2,500, that's 1. And 1 times m is m. Now notice the meters cubed, the units, cancel. Meters cubed divided by meters cubed is 1. Okay. Over here, I have 2,500 meters cubed times 997 kilograms per 1 meter cubed. Again, the units cancel. Meters cubed divided by meters cubed go away. And I have 2,500 times 997 kilograms. Let's go to our calculator here. 2,500 times 997. And we get 2,492,500. So I know that m equals, I'll just write it, I'll just round to the nearest, we'll just call that 2.5 million. So we'll do 2,500,000, we'll round it, is roughly equal to m. Okay, so you notice my meters cubed and my meters cubed canceled. What's left? My units is kilograms. So it's roughly 2,500,000 kilograms is my mass. Okay, so I used the density of water that I looked up earlier. Okay, and I used the volume of the pool. I plugged in density, I plugged in volume, and I just solved for m. And there were a few more details here about the units. Okay, don't worry too much about that. If that blew your mind doing the units, then don't even include the units, and you'll still probably get the right answer because there isn't really many places to make a mistake other than that. Okay. Okay, so this next example is about my truck. My truck can carry 735 kilograms. Okay, it's over 1,000 pounds. How many spruce logs can it carry if each log has a volume of 0.05 meters cubed? So I'm hauling wood in my truck. I want to know how many logs can I put in my truck. Okay, suppose I've already calculated this volume using maybe the formula for a cylinder, because a log looks like a cylinder, and you guys hopefully learned how to calculate the volume of a cylinder in that last lesson. Okay, pi r squared height. So you could calculate the volume of a cylinder that way. And suppose you want to know how many of those cylinders you can put in your truck, which you know can carry this much weight. Okay. Well, we're dealing with spruce logs, and in the last video I actually had the density for spruce logs, 450 kilograms per meter cubed. So we'll write that down. We know that the density of spruce is 450 kilograms per cubic meter. Okay? We're going to use that because that tells us the relationship between the mass and the volume of spruce logs. Okay, let's use our formula. Density equals mass over volume. Well, there's D. I can pop that in there for D. 450. I'm going to put the units in here. Kilograms per cubic meter equals, there's D. What's my mass? Well, my maximum mass that my truck can carry is 735 kilograms. Okay, so I'll put that in for M over V. What's my volume? Now you might be tempted to put in this volume of a log, but remember we're trying to figure out what's the total volume that my truck can carry. There's the mass that my truck can carry. The volume of what my truck can carry is what we're trying to figure out. And once we know the total volume my truck can carry, then we can figure out how many logs because we know the volume per log. Okay? So I'm going to take this equation and solve for V. Okay? How do I get this V by itself? Well, maybe I want to multiply by V. Since V is being divided, the way that I can get it out of this denominator is by doing the opposite operation, right? We did this when we were doing SOHCAHTOA, when you had a variable in denominator. One way to get it out of the denominator is to multiply by it on both sides. So I'll multiply that side by V, and I'll multiply this side by V. Okay, so V divided by V is 1, and we're left with 735 kilograms on the right. And on the left we have 450 V, and our units on the left are still kilograms per cubic meter. Okay, I know this is the new part, having the units in here in the equation. You guys aren't used to that. Get in the habit of it because you'll be doing that a lot in science classes, okay? And science teachers are always pestering me about stuff that their students don't know how to do because they didn't learn it in math. Okay? Okay, so now to get rid of this, to cancel this V or divide this V, to get this V by itself, excuse me, I can divide by 450. Okay, so I'm going to divide by 450 on both sides. And I'll also divide by kilograms over, I'll also divide by my units as well. Just bring the units along with it. Okay, so everything over here, 450 divided by 450, and the units cancel, they divide each other out, so we're just left with V. And on this side, I have 735 over 450. But what are my units here? I have G divided by, I have kilograms divided by kilograms over meter cubed. I have a unit divided by a quotient of units. Okay, remember when you divide by a fraction or divide by a quotient, it's the same as if you multiply by that reciprocal, by the reciprocal of that fraction. Okay, so instead of doing kilogram divided by this fraction, kilogram over meter cubed, that's the same thing as kilograms times meters cubed over kilograms. And you get kilograms divided by kilograms equals 1, and you just get meters cubed. Okay. If you didn't like that, don't worry about it. If you don't bring the units with you in this equation, it should all work out. And if you just use common sense of what should the units be, it'll be okay. But this will be helpful. Bringing the units with you as you do the problem will be helpful as you progress in science classes especially. So now all we have to do is divide 735 by 450 to get our volume that our truck, the volume of wood, of spruce that our truck can carry. 735 divided by 450, 1.633. So our truck can carry a volume of 1.633 roughly meters cubed. Okay. Well, each log is 5/100ths of a cubic meter, and I can carry 1.633 of a cubic meter. All right, so how many of those are in here? What am I going to do with these two numbers? This is the total volume of wood that my truck can hold, and that's how much volume is in one log. So I want to know how many of those volumes is inside this volume. That's division. Okay, so the total volume that my truck can hold is 1.633, which is total volume, divide that by 0.05, which is volume of 1 log. If I divide those, 1.633 divided by 0.05, and we get 32.66 logs. That's a lot of logs, but that's the maximum carrying capacity, so I probably would want to put fewer logs than that in there. Okay, those are 2 examples of how to use density to solve some problems. Guys, I know this stuff might be tricky, might be difficult and confusing. Please see me during the office hours if you have questions. Send me a message on Remind if you have questions. I'd be happy to help you with this stuff. I know it's difficult. Definitely do that Khan Academy practice quiz. That I think you'll find is not too difficult, and that will certainly set you up for the Canvas quiz. Okay, that's all I got for now. Bye.